Although the United States had taken center stage with its successful Apollo program, the Soviet Union was not idle during this time either. Having lost the race, they could now move at their own independent pace in space exploration. On September 12, 1970, 14 months after Apollo 11, the Soviets launched a Proton rocket towards the Moon with a probe on board, the Luna 16. 8 days later, it landed on the Moon and began to collect soil and core samples. The robotic probe remained on the lunar surface for little over a day. Then the upper section of the probe was launched back into space, and on 24th of September, the probe and its 105 grams of lunar samples parachuted to Earth in the Soviet state of Kazakhstan. 2 months later, in November of 1970, Luna 17 soft lands on the Moon. It carries with it a robotic vehicle called Lunokhod-1, the first machine of its kind to reach another planet. Basically, it was a short vertical tube mounted on 8 wire wheels with a convex top which opened to reveal solar panels on the interior lid surface. This was deployed to recharge solar batteries when stationary. It also contained a polonium-210 heat source to keep its internal temperature at a safe operational level. At its front were several TV cameras, soil probes and antennae. The probe also housed an X-ray spectrometer, cosmic ray detector and X-ray telescope. It was intended to operate for 3 lunar days or 3 Earth months equivalent. It operated successfully for 11 months Earth time. The Lunokhod was controlled and driven by a 5-man team and traversed the lunar surface for over 10.54 kilometers, returning 206 panoramas and 20,000 TV images. It made 25 soil analyses and used its penetrometer at over 500 locations. Contact was lost September 14, 1971, and the probe officially shut down October 4th. Not content with the Moon, the Soviets launched another probe towards Venus with a specially designed lander to reach the surface of the mysterious planet. Venera 7's descent probe transmitted data on its 35-minute journey down to the surface, where it landed with the aid of parachutes. It continued to function and transmit data after the landing, the first probe to do so. It recorded atmospheric densities over 90 times that on Earth and a mean temperature of 475 degrees Celsius. It transmitted for 23 minutes on the surface before succumbing to the extreme environment. Apollo was not the only program being run by NASA at the time. Launched May 30th, 1971, Mariner 9 performed a 14-minute-long burn of its main propulsion motor to slow its speed enough to be captured by the gravity of Mars and become the first probe to successfully orbit another planet. And on November 13 began to map the entire Martian surface. Onboard sensors included 2 TV cameras, an infrared interferometer, ultraviolet spectrometer, and an infrared radiometer. Weighing only 545 kilograms, it took spectacular photos of major Martian landmarks and helped identify future possible landing sites. The Pioneer project was also continuing. Pioneer 10 consisted of a small probe weighing in at 270 kilograms. Its main components are the high-gain communications dish with a diameter of 2.7 meters, a main electronics housing, and controls for 6 thrusters. 2 truss booms extend 3.3 meters, each housing 2 radioisotope thermoelectric generators, each generating 40 watts at liftoff and slowly decaying. A third boom houses the helium vector magnetometer some 6 meters from the probe's body. Other instruments carried included a plasma analyzer, cosmic ray telescope, Geiger tube telescope, meteorite detector, ultraviolet and infrared photometers, and an imaging photopolarimeter. The probe also carried a special gold plaque on its side depicting humans, the Earth, and where the probe was from, and scientific symbols to help an alien race decipher the plaque's message. Pioneer 10 set off on tour March 2, 1972. This mission was to explore Jupiter, to get their required speed, firstly to escape Earth's gravitational field, then to move outward through the solar system, required the craft to fight the Sun's gravitational field. Boosted into orbit aboard an Atlas Centaur, a third solid booster stage, TE-3644, ignited, propelling the probe to a speed of 52,000 kilometers per hour. Pioneer became the fastest man-made object record holder by passing the Moon's orbit in 11 hours and Mars, at 80 million kilometers away, in just 12 weeks. Then came the probe's biggest challenge to date, the asteroid belt. Situated between the orbits of Mars and Jupiter, the asteroid belt is 80 million kilometers thick and consists of rock particles varying in size from dust motes to mountainous boulders the size of Alaska. All traveling at a stately 20 kilometers per second. By July the following year, Pioneer 10 had reached and safely passed through the asteroid belt. Soon, Pioneer was under the influence of Jupiter's gravitational field and began to accelerate towards the gigantic planet. During its close encounter with Jupiter, Pioneer 10 passed within 130,000 kilometers of the cloud tops, its cameras taking the first ever close-up pictures of Jupiter's atmosphere. Its onboard sensors also began recording, studying the intense magnetic and radiation fields of the planet, discovering the planet was predominantly liquid in structure. After passing by the planet, Pioneer 10 had gained momentum. In fact, the probe had been accelerated to 132,000 kilometers per hour. The slingshot effect launched the probe further out into the solar system. There it studied the solar winds, energetic particles from the sun, and cosmic radiation from outside our galaxy. The probe continued to relay its findings back to Earth until its scientific mission officially ended March 31st, 1997. The probe continued on its way, tracked by NASA's Deep Space Network, its signal still being picked up. Eventually, its onboard power supply had degraded to the point where the probe's signal was becoming too weak to detect. The last telemetry from the probe was received 27th April 2002. Its last signals were lost January 23rd, 2003. The probe was 12 billion kilometers from Earth. Pioneer 10 is probably the first man-made object to leave the solar system, although there is some debate as to whether it cleared the solar system's boundary shockwave before the later Voyager missions, which traveled at much greater speeds. Pioneer is headed in the general direction of the constellation of Taurus. The probe should reach the vicinity of its principal star, Aldebaran, some 53 light-years away, in 1,700,000 years. Pioneer 11 was launched 5th April 1973. Taking advantage of the position of the planets, this probe would follow its twin Pioneer 10 to Jupiter, then slingshot onwards to Saturn. Carrying one additional sensor package, a Fluxgate magnetometer, the probe was launched atop another Atlas Centaur with a third solid rocket stage. After passing through the asteroid belt, the Pioneer's onboard thrusters were fired to give it additional velocity. Reaching 43,000 kilometers above the cloud tops of Jupiter, Pioneer 11 took dramatic images of Jupiter's red spot and the polar regions. It also took a look at Callisto, one of Jupiter's moons. The gravity slingshot accelerated the probe to 175,000 kilometers per hour. It departed from Jupiter in search of Saturn. Passing through the ecliptic of the solar system to reach Saturn 1st September 1979, it flew within 21,000 kilometers of the cloud tops. Pioneer's scientific instruments and cameras took the first close-up images of the planet and discovered two previously unknown moons and an additional ring about the planet. It studied the magnetic and radiation fields surrounding the planet and also looked at Titan, its largest moon, one containing a dense atmosphere. Pioneer concluded that Titan was too cold to maintain life. Passing through the ring plane, Pioneer sends back fantastic pictures of the rings. Pioneer continued to explore the outer solar system, in particular the solar winds of energetic particles and cosmic radiation coming from deep space. The probe continued to be tracked by the Deep Space Tracking Network, and data was received until daily operations were shut down 30th September 1995. Intermittent contact was made for a further 2 months before the probe fell silent. Pioneer 11 is headed towards the constellation Aquila, also known as the Eagle, and will pass in the vicinity of the bright star Altair in around 4 million years. Closer to home, Mariner 10 was launched November 3, 1973. It utilized a gravity-assisted trajectory to swing by Venus and on to Mercury. Encountering Venus at a range of over 5,700 kilometers, the 433-kilogram probe studied the planet's outer atmosphere, including observations using an ultraviolet camera filter. Carrying a collection of instruments, including 2 narrow-angle cameras, digital tape recorder, infrared spectrometer, solar particle and magnetic field detectors, it traveled on to Mercury. The Mariner probe eventually became trapped in a solar orbit close to Mercury's orbit. As planned, it made 3 close passes of the planet. The first being the closest at 703 kilometers, where it took extensive photographs and made other observations. In total, Mariner took over 2,800 photos before exhausting its onboard maneuvering propellant. It also discovered Mercury has a tenuous atmosphere composed of helium and an iron core, which generates a magnetic field. Mapping over 45% of the planet's surface, Mariner deduced that the surface temperatures ranged from a nighttime of minus 183 Celsius up to a daytime 187 Celsius. Communications with the probe were lost March 1975. Mariner 10 was the last of the self-titled series. The next probe would be called Voyager. Cashing in on the success of their Mariner Mars mission, NASA launched 2 probes called Viking 1 and Viking 2. Each consisted of 2 elements. One, the orbiter that was to deliver the second element, the lander probe, to Mars orbit, determine the best landing site, relay the lander's radio signals, and thirdly, conduct its own scientific research in orbit. The orbital segment was almost identical to the successful Mariner probe, an octagonal shape with 4 solar panels protruding some 3 meters from its axis. Attached to this was the Viking lander, encased in a bio and heat shield container designed to protect both the lander and the planet from any unwanted earthly microbes. Viking 1 achieved Martian orbit 19th June 1976, and Viking 2 2 months later on 7th August. The car-sized landers made their descent and landed on 20th July and 3rd September respectively. Viking 1 was placed into a region called Chrysi Planitia, or the Golden Plain, in the western section of the planet. Viking 2 landed in the Utopia Planitia, 200 kilometers west of the crater Mie. Each lander was an uneven 6-sided platform with 3 opposing landing struts and footpads. Fuel tanks and radioisotopic power supplies were mounted around the platform base. On top of this base were the stereotopic cameras and a complex of sensors and instrumentation, including a small and very expensive biological laboratory designed to seek out signs of life in Martian soil samples. After entering the Martian atmosphere and aerobraking, the heat shield and bioshield are jettisoned, a parachute deployed, and thruster rockets mounted on the lander fired to cushion the landing. Once on the ground, communications antennae were deployed and operations commenced. A scoop from the side of the craft would dig into the soil and deposit a sample in the microlab within the probe. They included a gas chromatograph mass spectrometer and an X-ray fluorescence spectrometer. 4 tests were performed on Martian soil to determine if life existed in some form. The first heated the untreated Martian soil and through the gas chromatograph deduced the component molecules of the soil at varying temperatures. No substantial organic molecules were found. The second gas exchange test took a soil sample, added nutrients and water in an inert atmosphere of helium, and waited to see if any gases such as oxygen, carbon dioxide or methane were generated. A positive result would indicate microbial life interacting with the nutrients. None were detected. The third test, or tagged release test, involved adding radioisotopes to the soil with nutrients to see if any is released into the atmosphere, indicating a chemical exchange by microbes. This test proved positive, which, combined with the previous test negatives, only confused scientists further. The fourth test also involved radioactive tagging of soil samples in a Martian atmosphere, then heating the sample and measuring the resulting biomass. None was found. The Viking biological tests remain inconclusive. The probe also studied the Martian weather, seismology and atmosphere, as well as the Martian magnetic field, or the lack thereof. It seems the internal dynamo of Mars ceased functioning millennia ago. The Viking orbiters were the first to wear out. Viking 2's orbiter developed a fuel leak and was shut down almost 2 years later. Viking 1's orbiter ran out of maneuvering fuel after 4 years. On the surface, Viking 1 survived until November 1982, when during a software update, the craft was accidentally shut down due to human error. Viking 2's batteries finally died in April 1980 after 3 years and 7 months of service. The total cost of the Viking program was over $1 billion, an expensive unmanned exercise, but it lent much to the scientific and practical knowledge base of Mars well into the next century. Future Mars programs would have to be cheaper and rely on smaller, more elegant probes. The Soviets began researching and planning for more extended stays in space. In fact, they were aiming for a permanent presence in orbit. They launched the first so-called space station April 19, 1971. Salyut 1 was the first of a series of 9 single-unit space stations. It was 20 meters long and 4 meters in diameter, with an internal usable area a little under 100 cubic meters. Parked in a low Earth orbit, the first crew were sent aloft in Soyuz 10, but due to a locking mechanism fault, were unable to board the Salyut station. The second crew attempt was made by Soyuz 11 the following June 6th. The prime crew for Soyuz 11 was the space veteran Alexei Leonov, the first man to walk in space, along with Valery Kubasov and Pyotr Kolodin. 4 days prior to launch, a routine medical check found Kubasov may have contracted tuberculosis, and the entire crew was dropped and the backup crew put into orbit. Commander Georgy Dobrovolsky and Vladislav Volkov and Viktor Patsayev managed to board the station and remained there for 23 days, conducting extensive scientific research and proving long-term flight possible. Unfortunately, on its return to Earth, the Soyuz 11 capsule suffered a total pressurization loss, killing the 3-man crew, giving them the distinction of being the first spacefarers to die in space.